Hello everyone, my name is Abhishek and welcome back to my channel. So today is day 24 of our complete DevOps course, and in this class we'll be talking about Docker 0 to Hero. So first of all, if you haven't watched the previous video, that is day 23, I'll highly recommend you to watch that video because we covered the basics of containers. If somebody wants to understand what is the difference between virtual machine and a container, or if you want to understand the basics of container, the inception of containers, so definitely watch day 23 and only then proceed with day 24, that is today's class. Okay, now coming to the topic for today, we will be talking about what are the terminologies in Docker. Okay, so if you watch this GitHub repository, as I always do, I created a GitHub repository which will give you a clear understanding of the entire things that we are discussing in this video. Okay, so if you want to learn Docker, let's say you haven't followed the video completely, you can also start this repository, fork this repository, and you can do the exact same things that we are talking in the video. Okay, so don't forget to star and fork this repository. Now, going back to talk about the topics that we are going to cover today. First of all, I'll deep dive and explain you why containers are lightweight in nature. So in yesterday's class, I just gave you an overview saying that containers do not have a full operating system. They just have application plus application dependencies plus some required system dependencies to run your application, and remaining everything they use from the kernel or the host operating system, right? Even the diagram that I'm showing you here, which explains the same thing. On to your right side, there is a virtual machine which has a complete guest operating system. So that's why it's very heavy in nature. Whereas to your left side, you have a container that does not have an operating system. They just have some base image, or they just have some base operating system, and rest of the things they use from the host operating system, like the critical things like the kernel and all the important things they use from the host operating system, and very unique things that your container only required to create the isolation, they are present as part of your container or Docker image. Don't worry, I'll explain you this thing in a very detailed way. I've also mentioned the files and folders, exactly what are present inside a container against what are the files and folders that you usually have in a virtual machine and not in the container. Okay, so I have provided the description as well. So you can refer to this GitHub, or you can follow this video to understand why containers are lightweight in nature. Now, the next thing after that is I'll explain you the life cycle of Docker. Okay, because we want to create containers using Docker, so it is very important for you to understand how Docker behaves exactly, or Docker functions exactly. So I'm going to explain you the entire architecture of Docker. What are the different components that are involved in Docker? How do you interact with Docker? All of those things. Then we will get ourselves acquainted with the process of Docker. This is the architecture of Docker. But as a user, you have to perform certain actions through Docker CLI to actually build the Docker container, right? So the steps are like you have to write a Docker file, then you create a Docker image, and finally you create a Docker container. So we'll also get acquainted to that process. After that, a key thing is you need to understand the terminology. So terminology is nothing but the proper naming convention that people use in the community. Like let's say people say that Docker daemon. So you need to understand what a Docker daemon is, right? Sorry for that. Let me go back. Yeah, so you need to understand what a Docker daemon is. After that, you need to understand what a Docker image is, what a Docker file is, Docker registry, Docker desktop, and you have other things like Docker images. So we will understand all of these things with respect to naming convention and the terminology. Moving ahead, I'll show you how to install Docker on a virtual machine. Similarly, like our previous videos, I'll create a AWS. I have created an AWS EC2 instance for the purpose of this video. I'll show you how to install Docker on top of that virtual machine or EC2 instance. Then there are some quite common mistakes that people do, like as a beginner when you start with Docker after installation you run into some common mistakes. So I'll show you how to start your Docker daemon, grant access for your specific user so that you don't run into those issues. Then I have a folder in this specific repository which has a very basic Docker file, or you can consider it as your first Docker file. I'll show you how to write that specific first Docker file instead of using the same one that I have in my repository. You can also write your own Docker file by slightly modifying it, and then you can create your own Docker image and finally run your first Docker container, right? We will do all of these things in the current video. And after that, I'll also show you how to push this Docker image onto a public registry so that you can share it with external world. And it is important to share it with external world because that is a real-time use case. Like when you create your Docker image for your real-world application as well, you have to share it with your customers. So it doesn't have to be public all the time. A registry can be private or public. So I'll show you how to push this image onto a private or public registry so that any customer or any people from the QE team can access this and verify the Docker container. So this is what we are going to do today, as this is part 1 of your DevOps Zero to Hero series. And in tomorrow's class, which is part 2 of this DevOps Zero to Hero, we will learn about the advanced concepts of Docker. Like instead of writing a simple Docker file, I'll show you how to write multi-stage Docker file. I'll show you how to reduce your Docker images size, because Docker images by definition have to be very less in the size. But most of the times, some people keep adding multiple components or multiple unnecessary packages to your Docker image and keep increasing the size of the Docker image. So I'll share you some best practices how to reduce the size. Then we will write more and more Docker files and execute Docker images. And finally, we will also talk about your Docker interview questions and some other things that are related to Docker. So this is going to be in 2 parts. So today's part, I'm going to start like I always tell you, please like this video. If you have any comments or if you have any feedback, definitely share that in the comment section, and also share this with your friends and colleagues. Okay, so the first and the very important thing, I also covered this in yesterday's video, but I want to deep dive today. Why are containers lightweight in nature? So if you want to explain this in an interview, I have got a very good explanation in the GitHub repository itself. So you can follow this repository as is, you can learn from this repository, and you can explain the same thing to your interviewer as well. But the main and the primary reason is that, like I always tell you, a virtual machine is a like whether a EC2 instance that you're creating or a virtual machine that you have created on top of a hypervisor, they have complete operating system, full operating system, or the guest operating system, because of which they are very heavy in nature. Like let's say you create a EC2 instance. Okay, so the EC2 instance that you have created, whether you use it to full extent or whether you don't use it, you still have to pay money for your AWS or your cloud provider. On a contrary, containers are very lightweight in nature. That means to say that on a specific virtual machine itself, you can create multiple containers, and if the containers are not running, they don't use resources from the kernel. What is a kernel? Kernel is part of your host operating system. Let's say you buy a physical infrastructure or you create a EC2 instance on AWS. It basically has an operating system that has a kernel. So kernel is heart of your operating system. Now you install Docker on top of it, and what Docker does is whenever it creates containers, it says that, okay, container, you can use all the required resources from the kernel, but you can only, like the base image of the container, or the container itself can have only minimum system dependencies. Now why the system dependencies have to be there? Because this container and this container have to be isolated. Like this can be container of project 1 and this can be container of project 2. If all of the things, like if container 1 is using all the resources from the kernel and container 2 is also using all the resources from the kernel, then that means to say that some hacker who is on container A can access the applications, or he can technically get into container B as well. So there has to be a logical isolation, right? Do you get it? So containers, even though like I say that they don't have complete operating system, but they need to have some part of logical isolation. Without that logical isolation, any people who can log into your Kubernetes cluster, any hacker who can get into your Kubernetes cluster or a specific container, he can get into your all the containers that are present on your cluster, which is like a dangerous hack, right? Or you are compromising with the security of your applications. So project A person should have logical isolation with project B, C, D, E, and F. So that can be done by using some system dependencies, and the rest of the things, all of these containers can be all of the containers can share from the kernel or the host operating system. Now, what are these files and folders that containers have inside them, and what are the resources that containers use from the host operating system? So this is an information that it's not that easy to find. So for that reason, what I've done is I have put this information here, so that whenever somebody wants to refer, they can directly refer from this GitHub page. And whenever you are preparing for the interviews, you can say the exact same thing in your interviews. Because many people say that okay, containers do not have operating system, but they don't have quite good understanding of what that sentence means. So that sentence means the same thing that I'm explaining you. That means containers have a base operating system, or they have a minimum system dependencies, and these system dependencies are definitely required to form a logical isolation from one container to another container. If that logical isolation is not there, or if that minimum system dependencies are not there, then however, if you manage to run your application on that specific container, let's say your hacker, or a hacker who is entering into your container, can typically get into all of the containers and compromise the security of your organization. Okay, now, like I told you, what are the files and folders that a container has within it? Like, you have a /bin folder that has the container binary execution files. Then you have sbin, which contains system binary execution files. Then you have etc. I think everybody is aware of etc, which contains the configuration files for various system services. Then you have /lib for your library files. You have /usr or /user, which contains user related files, /var for storing your log files and the other things, and /root, which is home directory for the root users. So this basic folders form a logical isolation from one container to another container. That means a container cannot share these files and folders with another container. If a container is sharing these files and folders, that means you are compromising the security of your container, or the other container is compromising the security with yourself. So that's why these files and folders are not used from the kernel, and they are basically part of your container image or your container base image. I hope this is clear now. Now, let us see what are the files and folders that containers use from the host operating system or from the kernel, right? Because these are not the files and folders that can form your complete virtual machine or complete virtual image or your operating system, right? There has to be lot more files. So that other files are, your host file system, the file system. Everybody understands a file system, right? Then your networking stack, then your system calls, namespaces, control groups. These are basically part of your kernel. Okay, so if you watch our video, I think video number 4, where I explained you Linux operating system, what are the different components of Linux operating system, why kernel is very important, what are the different components of kernel, you will definitely understand that these parts are mostly from the kernel. Like they are related to kernel, C groups, or your Linux networking namespaces. So these are the things you can use from your host operating system, and a logical isolation can be created by using these files and folders. So I definitely say to read through each and every line of the GitHub page that I have provided. I took a lot of time to write these things, so that anybody who is watching this video, they can get benefit during the interviews. So if you even manage to say the exact same thing, or 60 to 70% of these things during your interview, your interviewer will definitely understand that you have a very good understanding of containers. Like, the concept of containers itself means a lot, right? If you are going to implement Kubernetes, if you are going to implement your containers on cloud platforms, you need to have a very good understanding of containers. So this is how you get understanding of containers. Perfect. Now, how small is this image, right? So I always tell you that containers are very lightweight, but how much lightweight are they in general? So for explaining you, I took a very basic example. I took a very popular container image, that is Ubuntu official Docker image. Okay, so this is official Docker image. What does that mean? That this image is provided by Ubuntu itself. This is a container base image. Now, again, what is this container Ubuntu container base image? That means this Ubuntu container base image has all of these files and folders. Anybody who is implementing application on this Ubuntu base image, that application will use all of these files and folders from the Ubuntu official Docker image, and rest of the things, like the kernel related things, networking stack related things, or the file system related things, it will use from the host operating system or from the kernel, right? Make sense? Perfect. So now to explain you, this is official Ubuntu Docker image, and this image is just 28.16 MB on Linux AMD 64 platform. Okay, it is just 28.16 MB. If you compare it with a Ubuntu virtual machine image, like it can go up to 2.3 GB. So this is default one. You can definitely reduce the size of virtual image, and even you can reduce the size of this official Docker image. But if you take the basics, so on a basic, out of the box, this image is 28.16 MB, and here this one is 2.3 GB. So you can understand the difference, right? It is almost 100 times smaller. So this is the very good advantage of Docker. So instead of running one virtual machine, what you can do is you can run 10 to 20 or 30 to 40 containers on the same virtual machine, right? Depending on how much resources your containers are using from the host operating system. Okay, so there are cases where if your containers are using a lot of resources from your host operating system, or you can predefine your containers with resources, like saying that my container has to definitely start with 256 MB. So in such cases, this is not applicable. But by default, the beauty of the containers is if they are not running, then they will allow other containers to use the resources from the kernel or host operating system. So that's why you can run n number of containers depending on how much your containers are using from the operating system. So what is blocking the same thing on virtual machines? Because your virtual machines have individual guest operating system. So this kernel, all the resources that are used by the kernel will not allow other virtual machine to use resources from, like, application B in virtual machine B or virtual machine 2 cannot use the kernel related resources from virtual machine A. Okay, I think I explained this a lot of time. So if you still have any questions, definitely please provide me the timestamp saying that I did not understand at this point of time, and I'll definitely make a YouTube short video or any other video to explain you this even in further detail. But as I'm telling you, follow through this GitHub document. Read entirely the README file. You will definitely understand the concept of containers much, much better. Perfect. Now, moving ahead to the topic of Docker. Like I explained you everything about containers now. Now, if you move to Docker, what is Docker? Till yesterday, we were only talking about containers. Like I told you, Docker is just a platform. So what is this platform exactly? So a platform, you can simply understand, like, if you consider Docker as a technology, or if you consider Docker as a, concept, then Docker is a platform that implements this concept, right? Isn't very simple to understand. So if containerization is a concept, then Docker is a platform that implements this containerization. Okay, so that is a very simple definition of Docker. But if you want a textbook definition, you can again take it from here. Docker is a containerization platform that provides easy way to containerize your application, which means using Docker, you can build images, you can run, okay, blah, 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 blah. So even I have written this one. If you want to read through this definition, you can use this definition. But if you want to understand in very simple words, you can simply say that containerization is a concept and Docker implements containerization. So are there any other platforms that can implement this containerization? Definitely. So Pod1 is a very good competitor. So if you have heard this term called as Podman, or if you have at least heard this term called Podman, so basically it's a competitor you can consider as, and it addresses few uh, complicated problems of Docker. Like Docker is a centralized platform where it has only one Docker daemon, but do not go to Podman directly. So first of all, learn with Docker, because Docker is very easy to start with and understand the concept. Like even if you're running with some issues, you can easily figure out the problem that you're running into. You can easily find out the solution. So definitely start with Docker. And if you get very comfortable with Docker, you can move to concepts like Builda, Podman, Scopio. But those are the next level tools where you can go to them but get expertise with your Docker. Now, what is the architecture of Docker, right? So I explained you that Docker is a platform. Now, what is this platform? How this platform will let you create containers, or how this platform will let you push the container Docker images to a private or public registry. So it basically happens through your Docker client. So I'll show you how to install Docker, how to run the Docker commands and all of those things. Don't worry about it at all. But first of all, here, try to understand the architecture. Basically, as a client, or as using the Docker client, the CLI. what you can do is you can execute some commands which is received by the Docker daemon. What is Docker daemon? Docker daemon is a process that you are going to install. When I say you install Docker, that means you are actually installing the Docker daemon. Okay, I mean the heart of Docker is Docker daemon. So whenever you are running some Docker CLI commands, so these CLI commands are received by your Docker daemon and they are executed. So when they execute, they create Docker images, they create Docker containers, and finally using this Docker daemon itself, you can push your Docker images to your Docker registry. So what is heart of Docker? Docker daemon is the heart of Docker. If Docker daemon goes down, that means technically your Docker will stop functioning or your containers will stop working, because these containers are, they are running against this Docker daemon, and Docker daemon is the one that is listening to your containers. Okay, so this is the architecture. No, don't worry about this Docker commands, what these Docker commands are doing and all of these things. The primary purpose of showing you this picture is you understand the architecture where there is a client that is Docker CLI. So as a user, you use this Docker CLI to execute some Docker commands which are received by the Docker daemon, and Docker daemon ensures to create your requirement. Okay, if you're asking Docker build, then Docker daemon will build a Docker image for you. If you use the Docker client to execute a command called as Docker run, then it will create a container for you. If you are using the Docker client to execute a command called Docker pull, then Docker daemon will receive this command and it will basically pull the containers from your registry. It can be private or it can public. Now, how does Docker daemon understand what is your registry, like where are these images stored or where I have to push this? Firstly, you have to create an account with Docker Hub and you have to log into it. So let's not go till there. I'll explain you those steps, but for now, I hope you understood the architecture of Docker. So once you understand the architecture of Docker, you need to understand the life cycle of Docker. Okay. So because the concept of containers itself is complicated, after you understand the concept of container, the rest of the things is only using the Docker platform to create those things, right? If you understand the concept, if you understand how containers work and all those things, Docker is just a platform. And what does this platform do? This platform will allow you to create your Docker images or your containers and all of these things. So you can consider it just as a CLI tool, or you can consider it just as a daemon service that is receiving your request. So what is the life cycle of this daemon service? First of all, you as a user have to write a Docker file. What is a Docker file? So Docker file is basically a set of instructions. So set of instructions is like you tell Docker daemon that, okay, get me a base image. Like in the previous example, I showed you Ubuntu base image, right? So get me a Ubuntu base image. And inside that Ubuntu base image, okay, so this is my source code. Put my source code into your Docker image. And once you put the source code, run the specific commands. If it is a Node.js, run npm commands. If it is Python, run pip commands, so that all the application libraries and dependencies get installed inside this Docker image. Finally, you say execute this, run a local server, or run a specific set of commands so that the application gets started. So this is the set of instructions you write in Docker file. Now using the Docker CLI, you submit this Docker file to Docker daemon using the Docker build command, and it creates a Docker image for you. Once the Docker image is created, what is an image? Image is just like, if you compare it with a virtual machine, so image is just like a snapshot. So this Docker image can be executed, or this Docker image can be run. Once this Docker image is run using the Docker run command, what happens is this receives the Docker run command and it again creates a Docker container for you, right? So this Docker container is your final output, which has, like I always tell you, system dependencies, application libraries, and your application itself. So you can share this with this Docker container to anybody in the world using a public registry, and they can simply download this container and they can run your application anywhere. Like they can run your application irrespective of downloading even a single dependency, because your Docker container or your Docker image has already all of those things, right? They can simply download your Docker image, they can execute the Docker image, create a Docker container, and they can run it on any platform. So this is the beauty of it. So if you want to, like, let's say you want to do these steps manually, what you will do, you will download the application, you will create an EC2 instance. On this EC2 instance, you will run the application. Once you run the application, then what you will do is you will export the port, expose the port, you will do a lot of things. right, to run your application finally on a virtual machine or EC2 instance. So this problem is solved by Docker. Okay, apart from Docker containers being light in weight and all of the things, the other important thing Docker solves is the complexity. So it reduces your workflow a lot. Instead of user doing 100 manual actions, one person writes a Docker file. Okay, it can contain an application, it can contain your testing platform, it can contain anything. So anybody who executes this Docker image, everything is created out of the box. That means your Docker container is also helping you in efficiency. Perfect. So once you create this Docker container, let's say your Docker container is also created. Now you shared it with somebody and they have executed it. So that will be your end of Docker lifecycle. Unless you want to tear down this container, you want to do something else with this container. This is a basic workflow of your Docker service. After that, let me explain you what is the terminology of Docker. Okay, so people use many technical terms, right? So when you're working in an organization or when you're working in the open source, you also have to understand these terms and terminology. Without that, it is very difficult to catch what the other person is saying. So Docker daemon. What is a daemon? Daemon in Linux itself is like a service. Okay, so in Docker, Docker daemon or Docker D is basically something that listens to your Docker requests. Okay, so somebody using CLI sends you a request. So this Docker daemon is listening to that API request and it acts upon your request. So it's like a heart of your Docker. Then Docker client. I already explained you what Docker client is. So Docker desktop, ignore it for like 10-15 minutes, where after that you'll understand what Docker desktop is also. Docker registries. So this is very important. Now, what is a Docker registry? So registry is nothing but it's a place where you store your Docker images. Okay, so you share your Docker images with other persons in your organization or other persons in the world, right? So how do you share these things? So there has to be a centralized place. So that centralized place is nothing but like this is one of the popular Docker registries, that is Docker Hub. Okay, now what is Docker Hub? Docker Hub is a place where you share your Docker images with external world, or you can also use any private registry. So similar to Docker Hub, you can create your own private registry, and you can also create private repositories inside this Docker Hub, and you can share with only set of people. Okay, but if we don't go to that details now, you can consider Docker Hub is as a registry. You can create your own registries as well, where you share your images with other people. For example, we are using I showed you that we want to use Ubuntu, right? So what Ubuntu has done is, this is official Docker Ubuntu image. So Ubuntu as an organization, what they have done is they have created a Docker image. Okay, so this is the Docker image that they have created, and they said that okay, anybody in the world who wants to use Docker container image instead of using Ubuntu virtual image, they can simply download this one and they can start using it, or they can use this one in their Docker file, and on top of this base image they can add their application and they can run their Docker container. Okay, so your responsibility is firstly to create an account in Docker Hub. Okay, so don't get confused here. Docker Hub is one public registry. There can be any public registry that your organization is using. Okay, so this is a very popular one. So your organization might also use something like Quay.io. Okay, so Quay.io is another public registry. Okay, but even if it is a public registry, just like GitHub, in GitHub also you can create private repositories, right? So similarly, here also you can create some private registries and you can share only with certain set of people. So one common question is, what is the difference between GitHub and Docker Hub? Okay, so people like in an interview, somebody can ask you what is the difference between GitHub and Docker Hub. So GitHub is basically used to store your source code. Okay, so it's a version control system platform of our source code, whereas Docker Hub is again a version control platform for your Docker images. So here not you are not storing your source code, but here you are storing your Docker images. Sorry for that. Here you are storing your Docker images. Okay, so what you have to do first is you have to sign in. If you have an account, you can sign in. Let's say you don't have an account, you can click on sign up and you can create your first Docker account. So it's very basic steps. Just provide your username, email, password, and you can create an account with it. I already have an account, so I'm not creating here, but you shouldn't get any error here. Okay, so don't worry about it. Just provide all of these details and you will create your Docker login. Why you need to create a Docker login? Because in this video, in the future, like in next 15 minutes or in next 10 minutes, when we run our first Docker image, what we are going to do is we are going to share this Docker image with our friends, or we are going to share this Docker image with other persons in the world. Perfect. So this is about Docker registries. Okay. So if somebody asks you what is a registry, you can say that in container terminology, registry is a platform which you use to share your Docker images. And a registry can be a private registry, public registry, and even inside your private registry, you can create public registry, you can create private repositories, just like GitHub, right? But the only difference is this is a image sharing platform, whereas GitHub is a source code sharing platform. Then Dockerfile, I already explained you. Dockerfile is basically a file where you write set of instructions that you are sharing with the Docker daemon. Then images. Okay, images you already understood. Now let us proceed and let us install Docker. But before that, I'm going to show you what is the example that I'm going to show you today. Okay, so I am going to start with a very basic example. That is, if you go to the examples folder, you have something called as app.py. Now, what does this app.py has? It's just a very simple Python program, which when executed says hi or hello world. Okay, now if somebody wants to run this Python application on a virtual machine or on a EC2 instance, what will be the steps? So the first thing that they have to do is they have to create a EC2 instance. Okay, even if they want to run this on their laptop, what they have to do is firstly they have to install Python. Right after installing the Python, what they have to do, they have to install the pip, they have to install all the I mean, this is just a hello world, but if it has other requirements, they have to install all the required dependencies on an EC2 instance. Firstly, they have to create an EC2 instance, they have to select a virtual machine image for that. After that, they have to install Python 3, then they have to install pip dependencies, then they have to ensure that the Python 3 working or not. In some platforms they might have some issue with Python 3. Now you will see what is the advantage of Docker. So if you are using Docker, you are let's say you want to share this application with the QE team or your testing team. They don't have to do all of these things. They can just download your Docker image, they can run the Docker run command, and they can test the application. Okay, so let us start with installing the Docker. So for our convenience, what I've done is I've already created a EC2 instance. So this is the EC2 instance called Docker demo, and there is no special thing about this EC2 instance. I've not done anything on it till now. I just installed the EC2 instance that is with Ubuntu platform, because throughout our videos we are just using Ubuntu. So I thought I'll just continue with that. Okay, but you can install anything as well. Now let me take my terminal and let us start with the installation of Docker. Okay, so what I'll do here is let me create a folder called Docker. Okay, I'll firstly log into the EC2 instance itself. Okay, so I'm using the SSH command. I'm using my public key, PEM file in general, and I'm logging into my EC2 instance. So everybody knows this step, how to create an EC2 instance and how to log in. If you don't know, you can watch our previous videos, how to create EC2 instance on AWS. Let me clear the screen, right? So now we are logged into our EC2 instance. Now what I'll do is firstly, you can follow the GitHub as it is as well. Like, you can follow the same thing that is present in the GitHub. If you go here, I explained you how to install Docker. Just search for install Docker. You have the same steps, but anyways, I'm going to explain it on my own. So firstly, sudo is because you need access. Firstly, I'll update this repository using sudo apt update. Okay, so this might depend upon your usage. If you are already using your EC2 instance, it will take less time. If it is first time, it will take slightly more time. Okay, so what I'm doing now is I'm just updating my repositories. My apt repositories or apt repos are updated. After that, I'll use a command called sudo apt install docker.io -y. -y is just to say that, okay, I agree with it. Else Ubuntu will ask you, do you want to proceed or not? So I'm installing Docker now. See, it is very easy installation. All that I'm doing is I'm just using the sudo command. So what we are doing here, we are downloading the Docker, we are installing the Docker using the apt repositories. If you want to do it on your laptop, let's say you don't want to do it on an EC2 instance and you want to try it on your personal laptop, then the good thing or the best thing is you use Docker desktop. Okay, so if you search for Docker desktop, So what is Docker desktop? So basically many people might be using Windows laptop or they might be using Mac laptop. So instead of creating a EC2 instance or a virtual machine, and on top of the virtual machine, instead of running the Docker, what you can do is you can directly download this Docker desktop. So again, it will do the same thing. It will basically create a virtual machine, and on top of the virtual machine, it will do all of these things. But it will be unnoticed. You don't have to do a lot of things. Okay, so that's why if you are trying to do everything on your personal laptop, you can use Docker desktop. The link is very simple. Just search for Docker desktop, and you will find this option to install on Apple, Windows, and Linux. But if you are an EC2 instance, you don't even have to do all of those things. You can simply follow the guide, and like I showed you, I installed Docker, right? Sudo apt docker install docker.io -y. Okay, if you go to the history and see, this is the command. Okay, so I installed Docker now. Let me see if Docker is running or not. Okay, to verify if Docker is running or not, what you can do is sudo systemctl status Docker. Okay, and it says that Docker is active. That means the Docker is running, right? So let us try to see. Since Docker is running, I want to verify if Docker is ready to use or not. Okay, so the very simple command that I can use is docker run hello. Uh, what happened? Yeah, hello world. If I do it, you will see this error. Okay, so very first time, don't get confused with it. You will think that, okay, Docker is already installed, but why I'm getting permission denied? This is because you have installed Docker using sudo, right? And by default, Docker has to be installed using root user only. And Docker daemon, the one that I'm saying, it also executes using the root user. That is one more drawback of Docker. Okay, like I told you, there are a couple of drawbacks with Docker. One is the Docker daemon itself runs with the root user, and the other thing it's a single process. It's a monolithic process. So even if you don't have, I mean, if somebody gets to your Docker daemon, since Docker daemon runs using a root user, they can hack your entire system. And the other problem is that since your Docker requires permissions as a root user, then that can also be a compromise, right? So these are some of the issues, and it's a single process. So even if the Docker daemon goes down, then all your containers are affected. Mhm. So what you need to do is, because Docker is running as root, by default, your user, in my case, the Ubuntu user will not have access to it. So what I need to do is I need to use this command called as sudo user mod. So what I'm doing is I'm adding the Ubuntu user, okay, to Docker group. So what this command does is it will add Ubuntu user. This is the Ubuntu user to Docker group. Okay, so that is what the user mod command is doing. It is modifying the behavior of the Ubuntu user, and it is making it part of the Docker group. As you do it, now even after this, you will see the same error because you need to restart, or you need to just log out and again log in back. I hope the image is right one. I mean, I hope the IP address is the right one. Let's see. So now if I do docker run hello hyphen world, see, now you are able to run. That means don't forget to log in back. That means you have to log out and log in back. This is required because you have a user profile for your user. Okay, so this user profile is not by default activated. Either you can source your user profile, okay, using the source command, or else you can simply log out and log in back. So for the people who are not aware of the source command and how to source your user profile, you can simply log out and log in back. Okay, I don't want to complicate it. So for now, just understand that your user profile is not activated as soon as you add your user to any other group. So now Docker is installed and your Docker is up and running. So let us start with writing our first Docker file. What do we have to wait for, right? So let me clone my GitHub repository. So this is the GitHub repository. What I'll do is I'll just copy this URL and I'll say git clone the URL. So you will be able to clone the URL. Okay, so let me go to that specific repository, docker 02 hero ls, and perfect. I have a README file which we were looking into all through this video, and then I have the examples folder. Let me go to the examples folder. So you will see two files here in the example folder, that is app.py and first Docker file. So app.py, like I showed you, it just has a hello world. You can complicate this program as much as you want. right? Because as I told you, Docker will automate the entire thing. Even if you write a complicated Python application or if you write a basic Python application, the steps that end user have to say, or the steps that your customer or your SRE engineer or whoever using this Docker image, they have the same number of steps. That is, they just have to run the container. They don't have to do any additional thing. Now let us try to look at the Docker file to understand how to run this application. Okay, or like I told you, what we will do is, okay, what happened here? Yeah, first Docker file, I need to go to this folder. Okay, now Docker file. Now let me go to this Docker file. If you see this Docker file, what I'm doing is, firstly, I'm saying from Ubuntu latest. That means we have to get a base image for our Docker container. This is very, very important. And that is what I'm stressing from previous class as well. Your Docker container will have a base image. It doesn't mean that your Docker container will run without host operating system. So that's why I'm getting Ubuntu latest from Docker Hub. Why I'm getting from Docker Hub? Because I can get from a public registry. Okay, so I'm getting this information from a public registry. And what I have done is Ubuntu latest. That is, I'm using a Ubuntu image. You can use any image that you want. You can use Debian, you can use Alpine. Okay, and then I'm saying work directory. Work directory is nothing but on the Docker container, you are just using the cd command and you are moving to /app folder. You can ignore this as well for your first Docker file. Then I want to copy the contents here. Okay, so if you see here, what I have is okay, let me move that specific file, copy app.py to here. Okay, so this is my app.py, right? And this is my Docker file. What I'm saying in the Docker file is just copy the content. Okay, just copy the everything that is present in the same folder to /app. Why I'm copying to /app? Because I said my work directory is going to be /app. So all the commands that I'm going to execute inside this Docker image is going to be inside the /app folder. What happens if you don't provide this specific line? Then here you can say simply copy. Okay, so don't worry about this Docker commands. What are these Docker commands? I'll brief you through each and every Docker command in tomorrow's class, but this is our first Docker file. So I used very less Docker commands, and like in this class, you can just understand that, okay, I'm using this Docker command for running my first Docker image. And in tomorrow's class, Abhishek will explain all the Docker commands and how to use this Docker commands. So I use the work directory for basically forming or for basically telling my Docker image that every action that I perform should be on this specific folder. You can ignore this as well, or you can use this as well. So I'm copying the app.py onto this Docker image, and after that I am installing Python. Okay, why I'm installing Python? Because my application is a Python application and I want to get all of this information into the Docker image, so that next time when somebody runs the Docker image, they will also execute the same set of actions. I mean, they don't even execute because the Docker image is already created. They just run the container directly. Okay, provide all the dependencies that are required for your application, and finally you can ignore this one as well. Finally, just run a command called python3 app.py. Okay, so this cmd is basically used to it just acts as a command line, or it just acts as an entry point. So it is the first thing that you want to execute inside your Docker container. So python3 app.py, that means I am running this app.py. Okay, so now let us try to execute this one and see what will happen. Okay, so the execution commands and everything also I stored here. So you can directly go here and use the docker build command. Let me show you that. So this is the docker build command. Let me just copy it and use the same command. So let's see what happens. So once you run this command, what happens is, all of the actions that you have provided in the Docker file are executed in a sequential way. So Docker daemon is receiving the instructions in the Docker file using the docker build command, and it is executing. What was the command that I used? Let us go back and see. So it says docker build. Okay, so it is asking to build the Docker file. Dot represents that Docker file in the same directory. You don't have to provide all the time -f Docker file. You can simply say dot. So Docker build, and this is the tag that I'm giving. Okay, why I'm providing a tag? Because on your machine or on your laptop or on your EC2 instance, there can be hundreds of images. So if you're not using a tag, what happens is your image will be lost, or your image will be generally created with some commit ID, or sorry, it gets created with a Docker image ID, and that Docker image ID, it is very difficult to remember. So that's why always tag it. And so to tag it, it is very easy. So this is the login information of my Docker. So I created a Docker login, right? So this is the username of my Docker, and this is the repository that I'm going to use. Like similar to GitHub. So you use a GitHub user ID, and this is your repository. So when we actually push this image onto a registry, what happens is inside your username, there will be a repository that gets created similar to Ubuntu repository, and this is going to be tag. Like you can say v1, v2, v3, v4. Don't worry, I'll show you. Once we push it, you will understand it in a much better way. Why we use this Docker build command using a tag, you will understand when I actually push it, because you will see in live that okay, inside my user, inside the Docker registry, inside my user, there is a repository that got created, and the tag that we have given also got created. Okay, so the image build was successful. Now what I want to do is I want to execute this image and see how my application runs. Okay, so the main purpose of this is to run your application. So what is the command that you will use? Docker run -it, that is an interactive terminal. Okay, followed by the image ID. Just provide this. See, you got the output called hello world. Now this is just a command line application, so that's why you got output as hello world. What if this is a web application? So what happens is your application will start running on this specific machine, and you can access the application from your EC2 instance or from your browser. Okay, so because this is a very first application, I did not want to complicate it, so I want to keep it very simple. That's why we use a hello world application. Whereas if this is an application, let's say this application is a web application, or it's a 3-tier application, then the same things will be executed and you can see the application live on your browser. Okay, so are the things clear till now? Now the next thing is I want to share this application with my friends. So for that, like I told you, what I have to do is I have to log in first. Where I have to log in, I can simply use a command called docker login and use the username and password that you use to create your Docker account on Docker Hub. So username is Abhishek.Veeramalla. So this is a username that I use for my Docker, and password, I remember my password. Just save your password somewhere, or remember your password and execute your password. Your login is successful. Now what you can do is simply use a docker push command, docker push, and say this specific thing, colon latest. That means I'm just using my image. So I'm saying docker push followed by this specific thing. Now let us see what is going to happen. So it is saying it is going to push this image. Let us see where is it pushing and what is going to happen. As soon as this image is pushed, you are going to see that on my Docker Hub. Okay, let me log into Docker Hub meanwhile to show you. So this is Docker Hub. Just let us click on it and let us click on sign in. So I'll use the same user ID and password that I used there. This is my user, and continue on it. Okay, so I use the password as well. Now I logged into my Docker Hub. Okay, I have bunch of images. Don't worry about it. Let us see what is going to happen. So if you see here, my image got pushed. Now what is going to happen? So this is my Docker account, and inside my Docker account, Abhishek FI, my first Docker image got created. If you see here very carefully, it says few seconds ago. So few seconds ago, what happened is there is a new repository that got created that is called my first Docker image, and there is a new tag called latest. Like if you see, the tag is latest, and this is my Docker image. So if anybody in the world want to use this Docker image, they can see here it says public view. This is the Docker command, so they can simply use this Docker command. Okay, so this is for push. You can simply modify it. Let me go to the tag so that you can see that command. Okay, so this is the command. You can just copy this command. Okay, let's say I'll do it on my laptop or somewhere else, or for any other person. What they can do is they can simply use this command called docker pull. As soon as they run it, they'll get Docker image on their local. They can verify that using Docker images command. So using Docker images, you see that, okay, in my case, I already have it. But for somebody who do not have it, also using the Docker images command, they can see that image is now available on their personal laptop or EC2 instance. So this is how you run your first Docker image and first Docker container. So if you did not understand anything here, just provide me the timestamp and tell me. So one thing is you might not have understood about Docker commands. Don't worry about it. In part 2, that is in tomorrow's class, I'm going to explain you the Docker commands in detail. So if that is your concern, don't worry about it. But everybody follow this GitHub repository. Whoever is watching this repository, watching this video, definitely go through this GitHub repository, try it out by yourself. And there is very, very informative information, not just the things that I mentioned in the video, because I took a lot of time to write this repository and I've shared a lot of useful information. So even this will be very helpful for your interviews. I hope you like this video. If you have any feedback, definitely share that with me in the comment section. Like this video, share this video with your friends. And if you haven't subscribed, please subscribe to our channel. Thank you so much. I'll see you in the next video. Take care, everyone. Bye.